This is a walkthrough of problem 3 on exam 2 of module 8 in the book Problem Solving Guide for Electromagnetism and Optics. We have two current loops that share a common center. They are tilted at an angle theta with respect to each other. Here are two views. The radius of each loop is 8 centimeters. The current in each loop is 5 amps. The current is clockwise when viewed from the top in both loops. The magnitude of the magnetic field at the center of the loops is 50 microtesla. What is the angle theta? Well, we have to be able to look at the magnetic field vectors from each loop. A wire loop produces a magnetic field perpendicular to the plane of the loop at its center. So if we focus on the figure on the right here, if we use the right-hand rule and curl our fingers clockwise from the top, we see that the B field's pointing straight down. So the B field produced by the horizontal loop at the center is like that. The B field from this loop is also perpendicular to its plane at its center. So it's something like this. And these magnitudes are the same. Current in each is 5 amps. The radius of each is 8 centimeters. The vector sum of these two has a magnitude of 50 microtesla. We can get the magnitude of one of these fields. Mu naught I over 4 pi r. We know the radius is 8 centimeters, and it's one complete loop. So the angle the arc subtends is 2 pi. We can plug in the numbers. Current, the radius in meters, and the angle, and we get 39.3 microtesla for each one of these. And they sum to a magnitude of 50. The angle between the two vectors is the same as the angle between the loops. That's also theta. We can put it in there. How are we going to add these two vectors? We know the sum is 50 microtesla. Let's put an axis directly between them. There we go. This is where the magnetic field vector is going to sum to along this line. And each of these angles is theta over 2. So the component of B horizontal along this axis is B horizontal times cosine theta over 2. Same thing with the tilted one. So the net field is 2 times B horizontal cosine theta over 2, or 2 times B tilt cosine theta over 2, because B horizontal and B tilt are the same. We can substitute in the known, so we're going to keep it on this page so you can remember what the equation is. There's the 50 microtesla, which is the sum of the two fields. This is the contribution from 1, multiplied by 2 because there's 2 of them. And we take the cosine of this angle, which is theta over 2, and we get cosine of the angle is 0.623, taking the arc cosine of both sides. We get theta over 2 is 50.4 degrees, so theta is 100.8 degrees. It's bigger than 90. So this angle, this loop is tilted over here, past 90 degrees. That's the answer, but let's redraw this figure to scale. Looks like that. So here's 39.2. The component of the 39.2 along this line is 25 microtesla. Each one of these is contributing 25 microtesla along this line, and the total is 50 microtesla. That's the answer. That's problem 3.